Today we're going to continue our Cisco because I have not yet studied in this course from the motive team. So yeah, let's try what will be going on through this day. Okay, we have the internet protocol. Okay, maybe we can just scroll down this slides. Okay, sure, is it? I have serious case again. Okay, an IPv4 address identify a host required by networking devices to ensure the structure of IPv4 address. Okay, the purpose is and the structure. Okay, first one is the purpose. Participate on the internet, almost LANs today. Local area local area network. Particular host. Unique. .64. So we will come to the first one, www.cisco.com, right? Yeah. Oh, I forgot to share the slides. Okay, and move on. Okay, sorry guys, I forgot to share. Okay, IP address are 22 bits at length, octets. Okay, info 8 bit bytes called octets. Okay, you can count this. It has the meaning like it is 1 multiplied by power up to 0 times. So 1 is 0 multiplied by 0, 0, 1. This one is like 2 power up to 1 times, power up to 2 times, power up to 3 times, power up to 4 times is 16, power up to 5 times, 6 times is 64, 7 times is 128, plus all of this to calculate, and then we get 209. Okay, structure network in host. The logical 32-bit IPv4 is hierarchical. Hierarchical made up of 2 parts, network and host. The network on which the host is connected. Here's subnet mask. The first three octets identify the work portion of the address, and the last octet identifies the host. Network host. This will have this. Okay, because we have this. So this is the connect the network part, and this the whole part is 100. So network address, which is like we have to take note for the network. That's what is for the host. We work in the host 100. Subnet mask. It is like this. So the our network part is only this, and the host is the host number 4, and then we have 100. So just 00 is good. Okay, with this also. We have 3. So this is okay because we have 10 here. This is not 100 because we have 3, but it is the terabyte is 4. So also this is not okay. Yeah, just that. Next, Internet Protocol quiz. Oh gosh. Okay, I'll have to review this. Okay, it's funny. This is my first time. Okay, again, what criterion must follow? Each IP address must match the address that is assigned to the host by yes. No, it's actually not because we have different hosts. Let's be unique. We have this one compatible with the MAC address. No, of course. Unique network component. Network component? No, we can have two work in the same host. Octet is 5, 8. Oh, sorry, 8. Network portion, host portion. Purpose of subnet mask in conjunction with an IP address it is to define a subnet which the host belongs, or uniquely identify a host. I forgot this, which is like minutes before, right? Uh, mm, yeah, identify the network. Gosh. Okay, sorry guys, I have messages. Okay, it's used to identify the network on which the host is more green. Okay, that's nice. Maybe difference. Oh my gosh. um, it is. Technician is setting up equipment or network with three devices. We need IP addresses. So what is the purpose of IP address? Is like when we okay, I forgot. Oh, shit. Okay, it's to connect things, right? Workstations, interface, network interface card installed in a device. Yes. Trời ơi, gosh. A server with two TNICs, yeah. A printer but integrated, so if it's one only, so it's no need. Webcam is attached. It's attached directly to host, so it will attach directly. So there's no need also as well. IP4, maybe yes. And we need it because we have only card and NIC card only. Wireless mouse. Oh, I mean it's wireless, so it need right. All this PDA with network station, of course, because there are a lot of people in the network station. Right? Oh my gosh, it's difficult for me. Just try. Which statement describes a physical network, a logical Each a physical network can connect multiple devices. A physical network on different logical networks. It must be in the same IPv4 logical network, I guess. Yeah, it needs to belong. Um, well, physical network. Then, oh my gosh, this is my first time talking with someone new. This is just Peter, my friends. A local physical network supports one. No, it's not. Physical network. What is physical network? Physical network linked to multiple devices. Yes, I think. Hmm. Yes. No, it no need because we have a switch, right? The switch we can send from another one IP address to another IP address to the switch. What is the logical network? It means like the host also. It can be on a different host. Maybe this or large. Okay, this is 32 bits. What is the network number of with the subnet mask is we'll have this one and the zero. Choose two. Okay. Contains a alt text. No, it is for alt text. Yeah, it's logical addressing scheme. Hierarchical. Okay. Now it can be used like in some host. You can just transferring things. Oh, nice. Okay, this one. Is okay, it's not this. 670, 68, 68, 68, 22. Okay. And yeah, this one is routing. I think it's around not 100. Okay, it's 73. It's okay for me. Routing. Okay, good, good. It's good. Yes, and then I work well with the theories. Oh, yeah, of course. I mean, we have a good insight in this. Maybe this one could be the printer, like an IC and IP phone, or so it's C, right? Then maybe accepting which the host belongs. Oh, for octets. Yeah. Oh gosh, I don't know why I'm wrong in this. Obviously, still stupid man. Okay, just finish this and move on to this IPv forest networks. Types of okay, unicast, broadcast, and multicast. Okay, this is share things, right? Okay, and like sharing from one person to one person. It's all one to all. Limited broadcast is sent to. Okay, this is the destination. And the multicast. This means like moving to many people, right? That's all, but more than two, I think. Click start seeing destination and then next to the home which you will receive packet based on the address type. Okay, check unicast, broadcast, multicast. Okay, this um multicast, right? Oh, yeah, I see. What's this? I do not understand what's this. How can I try? How can I trace? I don't know how to work with this. Click the host or host which receive this address tab. What's this mean? Need to find a unique cast. Ah, unicast first, right? What's this? I don't understand how it works. What does this mean? I don't know. How is the unicast? It's one to one, right? The source, this one, shall is could be which I do not understand. Ah, so it's like we have the five here. Oh, okay, just do all of this. I can't understand this. What? Gosh. Okay, I'll get two. Get two. Then next we have broadcast. Why is this not going to the new one? Because I don't understand how to work with this. But like if we have a unicast, we will contact one to one. It should be on the same host because only one person. Next, we have the broadcast is shared to all of the people. Yes, and finally with the multicast, it is like we choose some of them. Or maybe once again, the cat will be like this. 1 minute to okay. I'm not sure again what. Oh yeah, it's we have gosh. Okay, just look for this new one. Grid routing to the internet. There's so different types of IPv4 addresses. This one, named address and prefix. What does the 8 stand for? I don't know. It's like a test, right? 8 mm, slash 8. It is look like yeah. Can this then the slash number of network bits in the subject. Okay, this one is represent the number of network bits in a subnet mask. Oh, with slash 16. 60 bits are the network for the network portion. So that the host would be like power of 232 minus 16 minus 2. Okay, so if I slash 8, it will be the subnet. The total is like 2 power of 2 with the 24. So there will be a lot of subnet. That's what it works. That's how it works. Okay, so it's like this. Is from this one to this one, it should be around power of 2 with 24. This forms with 12. So there's 31 here, not 155 here. This one, okay, there's only okay 16, but we have done one, two octets, so we need only to fill in with the two octets only. Okay, and we're routing to okay translation network address translation NAT. Okay, activity. Oh gosh, what is this? Oh, it is private of not. Okay, again we have this one is passed because the public. The private is only around this one, this block. Okay, it's not public. It's private. This one is passed. This is around 10, 0 to 10, 2 to 10, and then 500, blah, blah, blah. Yeah, also with the 192, 168. The difference is with the 172. We can count from 16 to 31 only. And this is the range. This one we can see 0, 0. And then all of this, yeah, 168, all of this into that. Only this network, yeah, network portion. The host portion will be everything. So with the 10, there's only the network portion 10, and the host is going to be only all of those things. With the 172, we have only from 16 to 31. Okay, got it, got it. Just can use the thing in the loopback interface. The ping command, okay, just to test, load up test now. You can see class for addressing. Class A, extremely large networks. It's really come from 0 to 127 plus B, or large sum power to 60,000 host addresses. Fixed mass 60, okay, will be from 128 into 191. The class C, okay, what we often use 192 to 300, 223. Okay, what is like 2, 0 from 2 power of 4 to 6, 6 times. Yeah, 6 times minus 1. And then we have class B from 224 until 239. Class E block, experimental multitask block. Okay, 255. Okay, you have this diagram. Okay, yes, and 16, 102, okay, private. Okay, 192, 168, private. This not because we have 0, not 168. It's public, public, private, private, of course. Public. Oh, no, it's private. It's 10. 10 is always private. Mm, okay. RIRs. Public IP social information. Yes, we have the IPv6 now. Must be a yes. One is private. Organization's internet internal, so it's not public. It's private. Yes, it's a large. It's not private. No, internet routers. The routers we connect with the internet from our from the ISP. So it will be public, and the private is SNP. Yes, the private we should have the internet network, but with the internet broadcast domain segmentation, broadcast domain. Okay, routers do not propagate broadcast. Router receive a broadcast. Okay, large broadcast domain. Reduce the size of network to a smaller broadcast domains. A smaller, okay. 400 users in LAN 1 with network address have been divided into subnets up to 10 user each. Okay, of course, we can see that this one broadcast only propagated within the small broadcast domains. Therefore, broadcasting LAN 1 can then propagate to LAN 2. Okay. Click image. Oh yeah, it's like a floor. Group of function. We have kind of how to separate groups. Device type. Okay. Okay, router will not forward IP packet by default. This one, okay, it's good, right? So network provision, so device, slow the device operations. Or is it? The quiz. Which statements describe what purpose of subnet mask setting on which network the host is connected? Okay, which network? Okay, that's what a subnet. Okay, next subnet. B is not correct. C is also not. Okay, it's A. Is multicast. Oh, on a broadcast. Remote network. What is directly limited? Is it limited? Is public. Oh, um, 69 is not private. This one is not experimental. Is around 239 come to 255. Link local. Maybe this. I guess I don't remember. I've read about it before. Private. Okay, of course 10. 32 no. 67 no. 16 okay. 68 okay. Okay, so this one is experimental, of course. This one is public. Or what is between? I don't understand which one. If try to figure out which one is like link local or yeah, I don't feel so. Class A Monterey. I don't know what is the type of link local. It should be that's right. But this work address we need to test for host addresses is for what for a large period. Okay. Multicast is class D of course. I don't know what's the name. Okay, just try. I think. The is more. This one is smaller than this one, of course. So maybe it's the back. Is it? I don't know. Just try. Device can serve as battery, router. I IANA. Um, what is this? Standards. It is. Gosh. Prefix of multicast. You can see this. Or S2. Yes, 243, 239. A high school with another high school in Russia. Okay, because of course private IP they have this broadcast or host. in the same network. Of course, it should be on the same network. Always again, but it's 73. It's okay. Yeah, it's directed. Okay, it's directed. Or link local. Class C is link local. Okay. Public. Oh, plus it's not a public. Look back. Allocation H IP addresses. Okay. Fine, fine. Next. Oh, okay, you can see that after learned this yet. We have to do today was around 5 more sessions. It's kind of takes yeah. Mm-hmm. Okay, so we use year IPv4 exhaustion days. June, July, okay, April. Wow. So South America is the fastest, right? Okay. What specifically to move to IPv6 will insist and in future and it will take several years. Protocols and tools to help your organization to migrate the networks to IPv6 dual stack on the same network segment when both need okay when both on this dual stack tunneling over okay encapsulated inside an IPv4 package dual stack okay we encapsulated in translation also you use a translation it looks good it takes time of course yeah okay but I guess of course everything good yeah we've covered if the ability is okay we don't need the IPv6 with all of them yeah all of the both oh yeah dual stack translation is the native is it oh this one we translating things. This one will encapsulate IPv6 under the MVP and IPv4. The first one we can 36 all of them. Okay, I see. hexadecimal number. Hex text or have octet text in the hex text. Written formatted. Okay. The string of hexadecimal values. Every 4 bits is printed by a single hexadecimal digit. There are 2 hexadecimal values. Not case sensitive, it can be written either lowercase or uppercase. Okay. For hexadecimal digits, 16 binary digits. Okay. Preferred format. The video we go on show consisting of 4 hexadecimal values, octet, 8 bits, 60 bits, 1, 2, 3, 4, 5, 6, 8. Okay. It should be 8 times 16 bits.
IPv6 addresses are 128 bits in length and written as a hextet. When written with all 32 hexadecimal digits, this is known as the preferred format, which doesn't mean it is always the preferred way to display the address. There are 2 rules which can be used to reduce the number of hexadecimal digits used to represent an IPv6 address. The first rule to help reduce the notation of IPv6 addresses is to omit any leading zeros in any hextet. We are using spaces on each side of the colon to make it easier to read. In our first example, notice that only leading zeros have been omitted. Here is our next example. Once again, you can see that only leading zeros have been omitted, not trailing zeros. And the same holds true for our last example.
Written.
You will notice that in all 3 examples, only leading zeros were omitted, not trailing zeros. Otherwise, you can see that we wouldn't know which zeros were omitted, leading zeros, trailing zeros, or both.
The final one, if they are over
Using
zero,
this first rule, we know that it is only leading zeros that are omitted. The second rule can be used to further reduce the representation of an IPv6 address. Any single contiguous string of 1 or more 16-bit segments consisting of all zeros can be represented with a double colon. In our first example, we begin by using the first rule to omit IPv6 network address. The double colon can be used on compressed address and hextets. We begin by omitting leading rule is applied, which shows 3 contiguous all zero hextets.
Oh, okay.
Applying both of these rules gives us the following compressed address.
1 or more,
and once again, here's what the address would actually look like. And now for our last example, we begin by omitting leading zeros. Then the second rule is applied, which shows 4 contiguous all zero hextets.
Spaces, so there's
Applying
no need to
both
write
of these rules gives us the following compressed address. And once again, here's what the address would actually look like.
Or the start is 0 or 0.
Notice the double colon occurs at the end of our address. The all zeros at the end of an IPv6 address is associated with an IPv6 network address within an address. Otherwise, there
double colon only once
would be more than one possible resulting address. If an address has more than one contiguous string of all zero hextets, The best practice
one will
is
have
to
this,
use the
right?
double colon on the longest
Return
string
to the only one
and
zero
apply the
double colon.
omitting leading zero. The first string should use the double colon, but typically it comes down to or equal. The first string should use the double colon, but typically it comes down to personal preference.
Oh, so only contain double colon one time. Okay, omit leading zeros. I understand this. It's fine for me. It's not difficult. Oh yes, it's absolutely easy. Double colon. Okay, we can try this as an actions, I think. Okay, but we have omit leading zeros. Okay, do this. Try these exercises. I mean, there is no tab, right? I also have tab. 101, 1111, and then refer to FE80 columns. Okay, 101, one double column. 101. 101, 1111, FE80 columns. 101. Oh, what the fuck? It's just like a similar of what I do, right? It looks 101. Oh my gosh, too much things. Deviate, column, 2, 4, 7, 8, 9, 10, 1, 11, 12, 11, 13. Yeah, it's fine. It looks nice. I work well on this. Okay, and this is how the double columns work, right? And then go to 6678, 9101, and then we have to write the zeros here, 0 here, 24AB. Oh, okay, check. Compressed format. FE80, okay. 6678, okay. Double columns, okay. Like what? Okay. Okay. Show me. Oh, like related. Oh, also. Oh, right. So that's something I missed in the present, the videos. This kind of like things. I have missed something, right? Oh, okay. It's healthy to learn things. Oh, yeah, it look kind of interesting doing these things. Check. Next. I mean, it should be the final one. Oh my gosh. Oh my goodness, there's nothing new. So this one not mute, right? Like different. Okay, I will want to do this one once again. Oh, this one will do it right. Okay, nothing new. Next. Quiz. Okay, of course. More addresses. What was the reason? Okay, is the depletion. A, B, C, D, E, F, G. Sorry, guys. This dual task. What the matters is to shorten the IPv6 address limitation. Okay, and then emit all zero to represent a string of all zero hex text string the same non-zero value. Non-zero is no, it's not non-zero. It's my fault. Okay, tunneling. Okay, it is continuous string of only zeros. Okay, to 128 devices in IP is the only way to communicate with. Okay, it's translating this NAT. Notation is valid. Think this one because I have that this one before, right? But in the video we can see that it should be this, not this. I do not know actually understand the concept of the exercises. 32 percentage. Okay, okay. A B A A B C. Okay, F is E. Oh, zero is represent for zero, so it is F. Okay, good. Wait, hold on the programming. I'm not good at this. Yes, one again we have okay. Invalid. Oh, ask for something invalid. Oh, it's wrong for me. So it should be the guys. Okay, I'm fine. It's C, of course. This one contain tree, which is not exactly true. So okay, so I'm obviously the solution of the IPv addressing is wrong. Next, dynamic. Okay, come on, go on, go on. Okay, static and dynamic addressing. Static, okay, compare them and then configure a DP. Next. What's this? IPv4 addresses is assigned either statically or dynamically. Mhm. When they have usual Windows servers, all the networking machines immediately accessible to clients on the network. If host normally access a server in a particular DP port would not be good if the address changed. Static provide increased control of networks because it can be them consuming into the information. Okay, is that the dynamic one? Or local or dynamic differences and local user population is yes. User laptops and connection. New workstations need to be connected. New process is assigned automatically protocol dynamic configuration protocol. Oh, it's the DHCP. What we often see today is called dynamic, which stands for dynamic host configuration protocol, such as IP address, netmask, default gateway, or the configuration information as shown in the figure. Okay, the HCP. Okay, we home regulation small business queues wireless router modem. It's both a DHCP client and server. Right, and client to receive IPv configuration as being access on the HCP server for the internal host on the local network. The router receives the IPv from address from ISP and gets through a HCP server. It distributes private addresses to internal host. Okay. Again, wireless router is both client to receive IP from the ISP. Okay, from the ISP we receive the IPv for configuration receive from this, and then it will act as a DHCP of internal host. And then it will provide information to the DHCP server on the local host, local network. Next, we see the public display at DHCP server again to the internal host. Okay. PC-based servers and wireless routers are the types of networking events that dedicate resources can provide the HCP service to clients. This is not as common. I do not know. Who is responsible for statically assigning IP addressing information? The statically assigning IP address information. Statically assigning IP addressing information. So it is the operating should be responsible by not the user of the server device. So the manufacturer, this I think is the new administrator, like always we have threat when we connect it automatically. There should be this, I think. Yeah, as an IP address information is more common. Network administrator protocol is responsible for out of as an IP address with DHCP. Okay, next configuration. But I wanted to check it once again and say deeply. Okay, have some advantages you use for this. Really good. Yeah, provide good control. Yeah, we have to control things. So of course, like have the authorities to do it. Yeah, this one the host uses to access internet or to another remote network. Okay. And the dynamic is like we can automatically connect to this. Just offset the mask. Okay. The HCP v4 version configuration. I'm too lazy to quit watching these videos, but I would. How does it work? Always need to.
The protocol, what this packet is doing is actually looking for a DHCP server. The packet is a broadcast packet, and it contains the MAC address of the device requesting the IP address, and it is destined for any device on the network that's configured to be a DHCP server. What kind of devices can be DHCP servers? Well, typically in a home network, the home router, the wireless router or the wired router, is configured to give out DHCP. In larger environments, often this is a server that would be doing other functions like Microsoft domain controlling, or it might be a Linux server that also doubles as a web server. So basically, the DHCP server can be a number of different types of devices. So when the DHCP discover goes out, since it is a broadcast, any DHCP server attached to the network will hear that. The DHCP server then responds with a DHCP offer. The DHCP offer packet contains an IP address that the host, the individual device, could use if it accepts it. When the host receives the DHCP offer packet from the DHCP server containing the IP address, and here's the IP address that was sent, and the subnet mask, as well as the default gateway address.
Default gateway.
Once the host receives that, it sends back a DHCP request packet that it will accept the offer. And it will request the IP address that the server had sent it, 192.168.1.15. The device will then take this information and enter it into its IP address settings. And at that time, once the server receives the DHCP request, the server will send back a DHCP acknowledgement that will indicate to the host that the server is placing this IP address into its table associated with the MAC address that was sent from the host.
Oh, okay. Service configuration.
One way is to manually configure it, and the other way to do it to a DHCP enabled router. Basically what this is a very similar device to what you would have at home. If you look here on the device itself, you'll notice that this device has a switch port, an antenna for wireless, and an internet connection. Okay. This type of configuration is available on almost every home wireless router. So basically what we're going to do is we're going to go in and we're going to look at how DHCP is configured on this device. Most home devices, home networking devices, have a GUI interface to make it easy to set them up. In the case of this device, you can see that I have some settings that are basic router settings. In this, on this router, we are going to enable DHCP, and as you can see by default, it's normally enabled. And you can see that an IP address has been already assigned to the router interface that faces the LAN. When the automatic configuration is received by the PCs, they're going to see this address as their default gateway. Now, the way that DHCP is configured is a group of addresses are reserved on a particular network to be handed out to hosts one by one. If you look here at the settings, it will say that the DHCP range will start at 172.16.0.100. So if we save this configuration, and then we go to our PCs and enable each PC to get their IP address via DHCP rather than via the static configuration. So we're going to go to the desktop here, and we're going to look at our IP configuration, and then we're going to change it from the static configuration to getting its IP address via DHCP. And you will notice that immediately the device sent out a request for a DHCP address and received one from the DHCP server. You'll notice from the information that since this is the first PC to be configured for DHCP, I'm going to go ahead and ping one of the other PCs. We know that since I have the address 100,
yes,
the other two devices have the addresses 101 and 102. So we're going to try pinging both of those computers.
What's this? Ping. Where is 92? No.
And as you can see, we can reach that 101 computer, which is PC1 on our diagram.
Oh, it's switch.
And then
it's fine. In this activity, we'll complete the following objectives. Okay, just like this. Okay. For discover, okay. DHC, the client accepting IP address provided by the DHCP server. Wait a minute, let me remember because I'm just listening once. Server responding to the initial request. Initially, a message via DHCP server is discover, right? And then a pack. What is the package next? This one. I've done something different. Yes.
devices can be DHCP servers. Well, typically in a home network, the home router, the wireless router or the wired router, is configured to give out a server that would be doing other functions like Microsoft. A server can be a number of different types of devices. With the DHCP offer, receives the and placing this IP address into its table associated with the MAC address that was sent from the host.
Acknowledge a pack, right? So that's why I frequently write pack. It's acknowledge. Yes, I actually don't remember this. Yes, but I remember right. It is discovered and then offer. What's confusing was pack. It's ack. Yes. Okay, it's ack. Acknowledge. So it's like we find something, discover things, and then after the client discover the server, and the server offers IP address. Respond to the client. It's offered, and then the client will request to because we accept the IP address, we want to request to connect to the server, and the server yes will acknowledge that, and yeah, it's accepted. First, this one guarantees that every device that needs an address gets one. Oh, no, no. This one. Offer from the will request. I can actually accept your IP address to this. Should be public, right? After receipt is offered, I remember the flow. It's good. So it will enable multiple. Okay, this is gonna be a range. It's going around 100 to 149. So each the first one will be this. PC1 placed in the PC holder. Two weeks. Available IP address. Hmm, I do not remember if it's not work or not because it's a private. You have 2 weeks. We know. Yes. That's the working. I think so. The NCP, right? The HCP. Discover messages. Oh, this one is good. It's correct. This one host and the destination IP address. Oh, and try to file. So it's acknowledged. Oh, it's 15 guys. Okay, okay. I have to do it once. Okay, it's good for me. Reduce, yeah, virtually eliminates entry errors. Authorize and authorize second parameters. Oh, okay. Every device that is no guarantee that every address will get one. It's all. It's also unauthorized as well. It will not guarantee it. Configuration error. Yeah, it's first one. Issue. Why? Server. Okay. Oh, okay. That's why when this, it has no knowledge of it. So it was sent to this because we don't know where it's actually destination. Uh-huh. Not permanently assigned to a host. Ah, my gosh. Hmm? Okay. Understand the concept. Okay, next checkpoint exam. Okay, there's a lot to do tonight. Mm-hmm. Let's is 32. The average existing of host are shown. Okay, we have this physical address with IPv4. Host number is 2. The first 3 is the network connection. Mask is logical network 45. Okay. Configure to computer on network. Subnet mask. Like this. Uh-huh. The network above the area that is shown. Okay, yes. This one, network number. Helping a friend with home computer can no longer access. My static, I forgot this. Gosh, what's static? It would be improve network performance. Actually, there's things into this. Simplifies, it's not simplifies, but it's a need to easier to implement the security policies, I think. IP address, link local. Okay, again, this one. This is look back, experimental, private, link local. This one is private. Oh, looks nice. Private. Two oh one BB8 double colon AB. Oh no, we have OO as well. Double AB. AB00. Okay, 201 BB8 O ABOO. Binary disk. PVC packets are converted into IPv packets and vice versa. Its translation coexist. Is transported inside. Again, development when ETF began the development of the PV6. What is the goal of this technology? What was the goal? Implementing this technology is to leave discover because we broadcast to this then that not request. Okay, again, I've got a lot of done this. This is request, broadcast the request. Oh, it's only unicast because so oh, this one. Let's try. Don't think it's request. Just try once. PHP operation. If the clients receive several message from different servers, it's a meeting path. Now does this one also say broadcast request is okay. Ah, but if it's boosted, let's say it's unicast because only one writes. Not the C. This one. Oh, 85. Quite good, right? So it's nice. Oh, it's not static. Mm-hmm. Okay, right. Again, this is my fault. Making mistakes this once again. Good. Oh, good. Myself, I think. Good. Yeah, when broadcast. Yeah, I don't understand this. So only two is okay. You're good. Next. Party network. Oh my gosh, three more sessions is 8:30. Then fine. Network batteries. Then maybe I will not look at this. Host on different networks. Each interface on router is connected to a separate network. Okay, router. Okay, we'll finish reading it. Mm-hmm. No, the same network. Yeah, always have. Ah, so have the same different IP address. When we have what in this, okay. But this is unique for each. Okay, I understand this. This translation. Okay, not this one. Okay, move on to the please move on faster. I get to the same errand. Well, would the package be sent? The same local area network, right? Default gateway first. Same. Yeah, I didn't read this. Okay, it should be. Watch the video once.
In this lesson, we're going to talk about private IP networks and the need for network address translation when we go from a privately addressed network to a publicly addressed network. IPv4 addresses have two categories. The first one is private addressing. Private addressing is addresses that can be used within an organization. They work perfectly well. You can assign them to hosts. They can be routed between different networks. But when you need to go outside of your organization across the publicly addressed internet, you have to have a registered public IP address. Now, the people who designed IP reserved addresses that are assigned possible host addresses. So they're used for smaller organizations and smaller networks. 172.16 now uses 16 bits as identifying the network portion. So you can have many more. And 10, it only uses 8 bits for the network portion. So it's used primarily for very large enterprises. Now, if we have a network addressed with private addressing, as we do in our little organization here, we would have difficulty sending this traffic out to a server that is located on the internet. The internet will only route is actually represented on the internet with a publicly registered address. And we'll say that it's in the same network here, so it's 200.158.50. And then if my host here decides also to communicate with a device out on the internet, it would be added in the table and assigned another registered address. So to hosts out on the internet, I am represented by this registered address. So when my packet goes out my network, so it leaves me, when it comes up here, the source address is my privately assigned address, 192.168.1.15, and the destination address in my packet would be the 210.100.5 address of the destination server. When it comes up here, the router looks at its network address translation table and sees that I will be represented on the internet by this address. So it changes the packet, my little packet here. When it leaves, the packet then looks like the source address of 200.100.58.51 and the destination address of 210.100.5.5. So when the packet actually reaches the server will send its response back to my registered address that was assigned to me here. So it'll address
It's electrical. Okay. Okay. So fine. If in something. Okay. Okay, it is generate the gateway default to communicate with others network with other network on the remote networks only. Okay, analyze the default gateway here. Large privately addressed tools over the internet. So it's private IP, right? I'm kind of tired now. It's too much today, I think so. Sorry, go. No, so wait. Yes, I will try hard. It's just kind of too hard for me today. Tomorrow I will come back with programming, of course. It's private, right? Yeah. Next ARP process. What's this? MAC and IP MAC address for an IC network interface card. And logical is the IP address. Layer 2 physical. Ethernet MAC addresses. Okay, destination source. So IPv port destination. Okay. The layer 2 Ethernet frame contains the following. And then the 3 IP packets. Destination BBBB, source AA. Okay. Oh, what's this? Can we see this? This BB, but that's the source. The source is okay, but the destination, I don't think so. Ah, okay, understand it. CC. Okay, if they are in the same, so it's fine. Wait, here. Ah, this layer 1 will be like this because they're here, it is here, and you have to go in to this one router to make it public, which is third. And then it go to the switch, I think so, router like that. One router is switch router, and then we come to the instruction D because we did not get it. Yeah, the IP address is encapsulated, so it will not be changed or modified. Then finally, yeah, the same local network. Remote. Destination. Ah, yeah. I see. Like what we see in the layer 1. DHCP, right? Not ND, of course. When we are ARP, I think so. DNS. Oh, address resolution protocol. Oh, DHCP is for IP configuration. The MAC address we have. Just check it once again. determine the device MEC, and the neighbor is to the MEC address device IPv6. Broadcast domain. What's this? One setting. Use three-step process to convert to the MAC address. Sending creates a send frame address to broadcast MEC address. Content in the frame is a message with the IPv4 address of the intended destination host. Received broadcast frame and compares the IP inside a message with as configured to the original sending host. Received messages called ARP table. Okay, I see. Oh yeah, it's like ask all of them who are they, then this one, and yes, if it is, I will get it sent back. Yes, you can now. Okay, it's fine. Hexadecimal, hexadecimal for averages. Yeah, I remember this one, but link is only 12. Okay, Internet broadcast. No, except like we see in PC, yeah. On the same network. Oh, it's not discovery. I think so. Because yes, no. And then the host will reply it, request. I think. Yeah, broadcast. Host V request. Okay, it's discovered, and then they reply it. It will send this request, and then it will be broadcast. or maybe broadcast second. You think so? Or reply is the final service. Of course, broadcast is the second. If yeah, I think is this one. If it's matched with the IP address, it works. Reply. So we'll send out by the MAC address. No, it's not this one. Yeah, we know our IP address. Like we will ask send all of the things like our IP address to ask if your address one is called discovery, and then if yes, you will send a broadcast to this like, and yes, that's me. Let, let, we will get a request if there's you this information and reply to the sent tweet to topic. Yes, that's me. Is my address. So let's reply. Okay, process quiz. ARP protocol. Not this one. Maybe this. ARP request. Like this is. There is this. DHCP is gonna go through the MAC through something. This was going through on the 16 bits. In the hexadecimal. Request they received. Request or only by the target device. On the low treatment of the request. The local link. Okay. Next, which one first, right? Which addresses are mapped by ARP? H1, mm, of course, we will wrap our all parts. Mm, I don't know, processed, but the thing is that, oh, it will say something host 2 as well, I think. Here again from this one first, right? We text 10, okay, just move on. Here 16 is not a part added. Okay, as also work with online, so we need the physical address. No, what is? This one. Oh, for it. Review. Resolving an IPv4 address to an MAC address, okay. Intent ERP table, okay, good. This one is the default gateway ERP request. Of course, if in the local links, so it's only work on the local network. So it is the destination MAC address. All Ethernet network devices have a unique media address access control MAC address that is linked to the interface card. Direct data from a particular device to a specific network destination. Sending transfer a frame to the source to the, I think so. And what is priority to transfer data? Oh, what do this one? Another device on the same network, it sends a broadcast or IP request. In this case, the IP address of PC2. When we send something in the same local network, we should send a broadcast. Okay, ARP request. In this case, that IP address of PC2 sends an ARP reply with the PC2 MAC address. Broadcast ARP request. Okay, request, and then it will give us back reply. Okay, it's good. ARP or the address that shows the protocol. Like address to destination. Okay. Yeah. Okay. Okay. Yeah, that's right. It's nice. This one. Uh-huh. Device is not on the same local period. Send a packet to the default gate. Wait. Zero zero C 00 B4 12 F3. The router is the default. Oh, okay. Not know this. Okay, good. It's good as well. This router. Oh, destination IP addresses. DHCP is the IP address. Okay, I will reset it once again. Oh no, it takes time. I think so. Maybe do this. No, I'm not be good. Okay, it takes a long time. The need for routing. Okay, now we need routing. Mhm. Okay, examines these addresses. IP switch on router. Mhm. What's this? I choose 2. It's routing. Much video. Connected. The default gateway. Okay. Oh gosh, I think I managed to pass that. I don't understand so much deeply. Oh, I should be a bit tired. Yes, there is for gateway for each. Want to type it? H1 is the default gateway. In the router, right? So there must be this 172.16.0.50. Oh, yes, yes. You never knew. And I said, but it's like this, like this. 1 is the MAC address. Oh, the default gateway is the MAC address. Yeah, yeah, yeah. But with the routing is the MAC address the default gateway because and in this ARP process, we can say that um, okay, once again, come on, this will be local link request is this the just destination MAC address, right? Layer 2, layer 3, we're gonna have the IP address. I suppose so. Oh my gosh, I'm tired of thinking, right? Not this one because it's only for IP. Okay, not this one. So what this? But where is it? Oh yeah, this one. Okay, we can see that. Oh, this also this is one for the ARP. It will send us again the default is for the IP, and in the routing with the router also we have default gateway is the MAC address. Okay, good to get it. H2, so maybe it's still the same thing. Or what is the 10? Is it? Why is the gateway? I don't. Um, I couldn't, I couldn't catch up with this. Maybe this like 2 is gonna match with this. Oh, it could be that. Oh, I don't remember. Is it this? Then comment to the gateway 3 will be this. 192.16.0.15. 192. Yeah. Okay. Continue. Next, the routing table. What information on the IP packet does the router use to merge interface for the packet? IP packets. I understand the concept. If host A has an IP packet to send host B and host A has remember host B is on a different network, get in an internet frame with this of the SD4 gateway. Yeah, it's true. Yes, if it's an IP packet is on the other network, it should frame encapsulate it, go through the MAC address, destination MAC address of the default gateway. Default route is interface through which the router forwards all package contain a source IP network address that is not in the routing table. This contains this network address that is not in the routing table of the router. Default route is the interface through which the router forwards. Or in default route is all packets, right? Now have a route to this. It uses the default route. Is it this? I don't know what is. A packet contain a destination and being is not in the routing table. If it's not in the routing table, oh, okay. A host will send a packet to the default gateway when a different network. Yeah. Finally, it creates a local network areas. Finally, I'll come to this. Okay, specific to increase traffic. Performance, improved performance, invisible to those on other local network segments, provide increased security, improve network organization, use of routing, distribution layer. Yeah, slow traffic, of course, more complexity and expense. Create a LAN case summary. Yes, packet. Is it? Oh, yeah, maybe yes. But we choose this. I've done, yeah. I know, but just this. The host is never to incorrectly to host local on the remote network. Router play on the network is forwarding frame based on MAC address. Layer 2, okay. IP local network to remote network is the router. A switch. I think a switch. To allow IP communication between two separate networks is switch, right? Or the router. Oh, it's router. I forgot this. Just try. Okay, that's still fine. What if it's only router within an IP network to control host traffic? Not this, but this. Host H7 sends a packet with a destination IP. This is for all. R1, it will send Yeah, there are two header information. What the two reasons to install router to segment network? Oh gosh, 50% is good. Okay, destination IP address, of course. Receiving device, when to forward the packet to its destination. Yes, if it is, then the gateway cannot work incorrectly, so it cannot communicate with host or remote networks. When a computer sends a packet onto the network, the source and destination IP address forward packet to the correct destination work. Oh, okay. Which address should be configured as the default gateway address? These systems which are located in remote networks. IPv port address is yeah. Okay, okay. Router. Okay, sure. So this is the router. That link is to broadcast content in the local network. So broadcast, yes. It's not for what broadcast. No, some means the header is another network or is a broadcast. The header of the packet to determine if the destination ID is on another network or is a broadcast. So we're not forwarded because it's on the network. What is not forward broadcast? Okay, or just send broadcast. Need to respond to the broadcast. It is dropped. Yeah, the segment is to expand the network to new different geographic location. So create smaller broadcast domain. Routing table, sure. Finally drops the packet. By route to the destination network. So it's just drop. Okay, finally, the last final things. Which type of address can be shared? MIT register public IP address. Okay, it will be a large let's devices. Let's share a single. No, only not only a small. It is what all devices share a single public IPv4 address assigned to the wireless routing. Misconfigured, so I can now put remote neighbors. A home network is using NAT, the route to connect to the internet. So home network is a private area addresses through DHCP means to send packet to a web server on the internet. It will receive a registered public IP address. It should be statically, or it should be set to the external router interface. A network administrator investigates the user problem, which host on the same network to remote network. Okay, it's like the network administrator ping gateway address configured on the home is successful. Maybe incorrectly default. Try to ping the gateway. Did not work. This one is. What will happen if the default gateway address is incorrect? Okay. Refer to exhibit. Switches have a default configuration. Okay. Host A means you will host D. The host does not have the MAC address of the default gateway, which devices will receive the ARP request sent by host A. So receive the ARP request if does not have the default gateway. So only B and C because it does not have the default MAC address for the default gateway. So it cannot send order. The router, so only BC router R1. Which protocol is recommended for the MAC address or default gateway? IP? I don't think so. Address control, UDP, or TCP. The only thing we do is IRP, right? The switch maps each 2 times. Layer 3 address related to address. Two to three is like routers, right? Okay. A host needs to reach another host on a remote network. Has no mapping entries. The broadcast MAC address is to reach another host on a remote network but has no mapping. So set an ARP request. What's this? You cannot see this. PC0. ARP in the IPv4 network. It will list on the destination MAC address. It's important for the router to maintain an accurate routing table. Router is this one known. Change. Must be segment, so it's destination MAC address. Forward packets. Broadcast address. Router. Okay. Maybe I'm making strong then. Default gateway address. I'm a bit tired now. Yeah. Actually, operates on a wireless router and allows all LAN hosts to share a single internet routable address configured on the external interface. Can intimidate at the same time using this with devices in the same network with those yes. External router interface. It is what we call sorry, packet header. DHCP is the packet to web server. Yes, it's fine. Forward packets to remote networks. DB2. Yeah, default gateway. It's fine. Okay, next. Okay, I understand this. RP, reliable delivery of data. UDP is the unreliable delivery of data. DHCP is the IP addresses. NLP is confirm MAC address. Switch mapping layer 2 MAC address to layer 3 IP addresses. Okay. Just like to be overthinking. RP request sent when our host does not have an IP to MAC mapping for destination. Catch first. Send to okay. This is what we have when destination that then the host send ARP request. Don't notice purpose I believe per day without to specific MAC address when you send all the files. Use the gather information when reliable keyboard IP address to make these mappings. Okay. So at the network task to discover okay. Routers route tables to information, the addresses of neighbors, the best path. When received, a frame on the interface strips the header containing the source and destination MAC addresses from the frame, checks the routing table interface use set the packet to its destination, is then encapsulated in a new frame with different header information. This is when router receives packet using destination address and then uses the routing table search for the best path to go. So ARP often like to layer 3 of like routing is like examining the IP addresses to get the MAC address. K is for routing. And a week ago we have others we used to check for the MAC address. I don't remember the terminology, but yes, we have that. And then we're gonna host portions, so others are concerned with delivering packets to delivering packets to the network that a destination host is a member of. Delivering packets to host, there's nothing to them, but they are only concerned with the delivering the network that then host destination host is a member. Multiple networks to remain the best path. Forward packets based on the destination IP address. The default gateway is used to route packets less than for the remote networks. The address of first layer 3 device next to the same network. First layer 3 that connects to the same network. This is layer 3, right? The default gateway is used to route check packets destined from the remote networks. Trust of the first layer 3 device, the router interface that connects to the same network. Okay. Yeah. The default gateway it context. I mean, it context from other network, but okay. The default gateway connects to the local network, but it used for connecting with other network is packet forwarding and path selection. Yeah, reset. We have to finish it overall more than 70. Okay, again, we do not have to be overthinking at all. So misconfigured, so it's not the remote network. Register public IP address if the way fault gateway is not correctly, so we communicate now other networks. Oh, yeah, this one is correct. All devices, again, I understand this because if it's not a MAC address, default gateway storage is only contact in the local in a shared order. Mentions does every process take when a host need to build a frame. So it's a prerequisite to the Ethernet broadcast to discover the MAC address. Protocol is ARP to check for routing. Default gateway is purpose. Okay, purpose of ARP is to forward content. It has two. One is to obtain a specific MAC address. If we know that, so you can make the table for MAC address. Did I remember this? Just make it out. A host needs to reach another host. No. Has no mapping entries. So I just broadcast. Layer 2 to layer 3. Again, I will not be like this. Do not do stupid things. Why is it important to route to many character? Okay. Intent. Because we need to have the minimum best to reach the destination. Okay, you can see the IP address configuration. This type IP address. Description of the default gateway address. No, it's not in the cloud. Okay, the default gateway with this IP address, because it's like this is have the default. Then we connect to this router 1 local network, which determines the square encapsulation of the packet it passes to the network. Oh my gosh. The destination layer to address the frame does not change is forwarded. The layer 2 header is stripped from the frame and is received by each router. Okay, it's reassembled and the head. This one of a router is to, no, not this one. Not this one too. Yeah, then you connect multiple IP networks. Receives a packet. You should ask the destination IP address to get the destination MAC address. Primary function is path selection. What does the router do if it doesn't mean that the packet from network 1 should be forwarded to network 2? What's the letter? Gosh, I don't know. Oh, it's 80 is good. But it's not because it's my second attempt. Is there something wrong here? Okay, this one, there are not the answers. It's fine. When the router receives a frame on the interface, it strips the layer 2 frame header information from the frame. It checks the routing table which is used to send the packet. When the packet is encapsulated with new different source, is stripped from the frame. So it's the two things. We strip and then it will resample noise this one. Okay. Frame web source image make address from the frame. The router checks routing table to determine when to use inside the package to this destination, encapsulated with different header information. It reassembles both. No, only frame. I think so. Oh yeah, packets not with the frame different. The packet too. Yeah, new frame is not. It's the package. Yes, I like. Okay, the layer two with this. We got things going. We have the MAC address, IP address. Okay, we have the MAC address here and the MAC destination, and then we encapsulate it in the IP. Go to the IP address, you search for this. If we send the gateway, okay, of course. Then if we have, it will strip down and makes the data packet encapsulated in a new one with new header information. We can try to find in this IP address, and that's how it works. Okay, yeah, a long day, guys. Have a nice day. Thank you so much for being here.